Hey peeps, Tyrell here. This is my write-up for Forwardslash, a pretty hard Linux machine on HackTheBox. And this is actually my second write-up, so I'll tell later that I actually recorded the write-up for Cascade first. So anyways, let's start with an nmap scan. I already have the full port scan, and we can see that SSH and port 80 HTTP is open, and the HTTP server redirects us to forwardslash.htb. So if we try and go there, it will redirect us. And in order to follow that, we'll have to modify our host file. We enter the IP of the machine and the forwardslash.htb. Now, whenever we will try to access forwardslash.htb, it will understand it is that machine. Now, if we go to the website, we see it is a defaced website by some hackers called /gang, and they say that it uses the old website used automatic FTP logins, which will be used for getting the user later. And basically, if you try to enumerate or brute force any kind of directories or pages, there is nothing else than index.php. So what are we gonna do is brute force the subdomains for forwardslash.htb, and in order to do that, I'll be using wfuzz. .exe file means the format of the word list is a file, and we select the database common.txt as our word list. And let me just copy the link here. And we'll be modifying the headers. Now the server checks for the host attribute in any header of the request to see which subdomain is the client asking for. So we'll just use host fuzz. There is the fuzz word that we need to brute force .forwardslash.htb. And let's see what kind of output that gives us. Also, we should use IP for this link just in case. And we do see that the server replies with two kind of outputs, either 302 code or 400, and we don't need any of that. You can see that it either gives 0 words or 53 words, which is basically redirecting us to the forwardslash.htb, the main domain. So we can do hide words. Sorry about that. And we don't need 53 or 0. We let it run for some time. After quite a while, it finds a backup subdomain, and I do know it is the only one, so I will just kill the wfuzz right now. And we can add this backup as in our host file as another subdomain for /. Save it, and let's check that out. Going there, we are greeted with a login screen. We can try admin or stuff like that. But we do see that the password isn't correct for admin, so we sign up as any user and password. Log in with that credentials, and we see a dashboard. Now this dashboard consists of many different pages, the Hall of Fame, which has the best hackers from HackTheBox and the whole HackTheBox team. We also see a message for saving the earth, pretty cool. And we also see some things like resetting the password or changing the username. Of course, changing the username to admin won't do anything. This is a hard box, and it doesn't change anything. So anyways, the page we are looking for, the vulnerable page, is this change your profile picture one. As it quotes that it has been disabled due to a recent hack, and we can see that the URL bar and the submit button is disabled. But of course, we can use inspector and get rid of the disabled attribute for both of them. After doing so, we see that it is vulnerable to LFI, local file inclusion. So you can see we can do much of /slashes. So you'll go back a directory each time, and then we'll go to etc and read the password file. And it does that. So we also get to see that there are 2 users on this box. And now we can do this whole thing again in order to try and get the index.php file. Let's see if we can get that. And we get permission denied. Not that way. Why does it say that? We'll get to see later. So again, doing the same thing, but this time we'll be using PHP filters in order to encode the output of these reading these files and converting it into base64. As you can see, I already done this box, so there was the drop down, and I just selected this filter, which will encode the output into base64, and we get it. So this is index.php encoded, and we can use CyberChef to decode it, paste it in, and we can use from base64, and we see the whole index.php file. We also say that it uses sessions, so there might be chances of SQL database on the backend. So we can see like db.php or let's say config.php, and we get a hit. So config.php might contain the credentials for SQL database, and we can use the same method, the PHP filters, and in order to get that. You get the base64 encoded file and decode it. And we do see it is indeed the SQL configuration file containing a password, but it won't be necessary right now as this is a service and we cannot SSH in using this password. But we do see a comment telling that this is a temp TB configuration file. The old config is in a backup, which will be useful later for privilege escalation. So right now we can see that there isn't much interesting things here, so we will do dbuster. And let's see if we can get any other files or directories. After quite a while, we do see a api.php. Let's see if we can get that file. I already done this box, so here it is in the drop down. Sorry for that. Do the same thing, and we can see that this is the API it uses for getting the files. We see that it uses the file getContent function inbuilt in PHP, and of course we can modify the URL, which leads to LFI, and we can access any file. Also, we can use any PHP filters in it. So that aside, let's see if we can find anything else. We see a dev directory, which is actually forbidden for localhost. So if we try and go in, we get access denied. And it especially tells us that our IP is blocked and it will only get access to localhost. But as we are using LFI, it is of course done locally. So we can get the index.php from that dev directory using the PHP filters that just like we did earlier. And if you're wondering where did I get the syntax for this, you can just search for PHP filters LFI or something like that, and it will be the first link right here. So this just converts the resource to base64, encodes it, and gives us the output. We get the index.php from dev directory, and we can see here that it says that if the remote address isn't localhost, it just gets 403 access denied. And on the code, we see that it uses FTP protocol with these credentials right here, which is of course also used for SSH, and it tries to get some files using FTP, but it's not that useful. So basically we got the credential for chief user, and let's see if we can SSH in. Let me just clear everything. Pasting in the password, we get in. If we try to list the file, there is no user flag, so the user flag would be on the pain's home directory. So we'll have to escalate our privileges and get to the pain user. So now we'll use linpiece in order to see what kind of vectors can we use for privilege escalations. And I'll be using Python 3 and hosting a server on my machine. And on the remote machine, I'll use wget to get the linpiece.sh file. You can see right here that we got linpiece.sh, and let's make it executable and run it. As you can see, linpiece gives us much data to analyze, but as I have already done the box, I know where to look for, what to look for, and this box is pretty long, so I'll be just not analyzing anything else than necessary. Right here, this would look interesting, but it's nothing useful. Okay, so the thing here is this backup binary. It is actually a set UID binary, which means anything that this binary reads or executes is done by another user, and in this case it would be pain, so we would be able to escalate or read something that only pain can do. So let's try and run it. We see it's a pain's next-gen time-based backup viewer, and it displays the current time and tries to get some file, which seems like the MD5 hash of something, and of course fails because there is no file named like that. So now I do know this MD5 hash is of this current time that is being displayed, this format itself of the current time, so we will have to replicate that format. For that, I'll be using the date command. So as you can see, using date, we can get the exact timestamp. Even this binary uses date for getting that format of timestamp. So let me just consult the help, and let's see if we can get the hours in. %m for minute, and we need the colon in between, and %s for seconds. So we get the exact format for the timestamp, as we can confirm right here. Now we need the MD5 sum of that, and we also don't need that last minus thing. We just use dr truncat to delete that, and let's see if we have the matching hashes. In order to do that, we should write a script which would do this whole command and then execute the binary so we can see if the hash matches. So right now all I did was do that command and run the binary so we can see if the hash matches, and we do see it doesn't. So yeah, the thing is the date command actually prints a new line after that, the \n, and we do not need that because it interferes with the MD5 sum and changes it. So I'll be again using dr truncat and deleting the new line. We can run the script again, and this time we get the exact same hash. So all we need to do now is make a file named with that hash and link it using symbolic link with any file which we cannot access but pain can, and using that we will be viewing that file. So anyways, if we go to war backups, we do see that config.php.back, which is actually the old config file containing the password for pain user. So I'll be making a symbolic link to this file and the location, the original file, will be named after the MD5 hash of the current timestamp. And using that, we'll be able to access that file. So let me just edit the script. So all I did was make a variable called time, assign the date, the MD5 hash that we get using the date and MD5 sum command to that variable, and then just make a symbolic link of the config.php.back file. And let me just confirm the name. Yes, it is true. And we'll be making a new file on our home directory named with the MD5 hash of the current timestamp, and hopefully the binary will access it. And because of the symbolic link, it will actually access the config.php.back file, which only Paint can access. So we'll be able to get that old password using this symbolic link. Let's try that. Well, that didn't work. Let me see what happened. Okay, after much time, I was able to get the right syntax, and turns out I was on the temp directory, whereas I was supposed to be in the home directory for Shiv user, because we created that new file in that directory. So I'll just move the script there, go there, and you can see the script is there. Let's try and run it, and we get the file. So let me just explain this script real quick. All it did was assign a time variable to using this dollar and in bracket the command, so anything which the command outputs is actually assigned to that time variable, which will be the MD5 hash. Then using that time variable, we create a file named with that MD5 hash, and we do a symbolic link to this config.php.back file. And in our script, we assign this time variable the MD5 hash of this current timestamp format, and we create a file using that MD5 hash being that name of that file. And all the backup binary does is actually just get that. So while it does that, we have the symbolic link for this backup file, and it actually gets that file. And as this is a setuid binary, it is able to do that. All it does is get this file name, and of course it gets the php.back file because we linked it to that file. So hopefully you guys understood. This is, of course, I'm not going into much detail. So anyways, we get the password, we ssh in as the Paint user. Pasting in the password, we get in. So let's see. It has the user.txt, so we got the user successfully. And it also has a not.txt. Let's see. All it says is that the Paint guy actually encrypted a sensitive file, and unless these hackers are some crypto expert, they should be good to go. So we got to decrypt something, or this ends at that. And doing sudo tackle, we do see that we are able to run these three commands as root user. So what are these three commands? The first one, crypt setup, all it does is map some backup, especially encrypted backups, and it can map that backups to a device. And we do see a star here that this means that anything can be here. It doesn't matter, the sudo doesn't annoy us. If any file is mentioned there, it doesn't care. The next command is actually mounting that backup device to the MNT folder. And the third one is unmounted, so that any other player doing this box cannot cheat or just get the flag easily. So we see an encryptorinator folder in there, and it has two files, a cipher text, which is of course, if we try XSD, it is encrypted. As we can see, these hexadecimals, they are basically unreadable, and we decide to see the encryptor.py Python file. And we can see here it was used for encrypting something and then decrypting it as well. So it has two functions, and it does something with the ASCII value of the characters, and we can see that it can also encrypt and decrypt. So all you need to do is basically it needs the key, and we have the message, the ciphertext, and the key we need to brute force actually. So in order to do that, we'll have to modify this Python script, and in order to do that, I'll have to have this ciphertext and this script on my machine. Again, I'll be using wget in order to get those files, and Python through is HTTP server on /. After getting the files, we list the files and we see there's 2 files still intact, and now we can modify the script and brute force the key. First thing I'll do is remove these unnecessary print statements, and then I'll open the Rocky word list, which will be used for brute forcing the key. Next, I'll open the ciphertext, again in read-only mode. Here, this read will mean that we are able to open the ciphertext and assign it to the cipher variable. Now we'll reiterate over all the lines on the Rocky word list, and of course each and every line will contain one word which we'll use as a key. And again, using the decrypt function, we'll use that same word as key and the cipher. Here I used our strip to remove all the unnecessary things, such as \n's, new lines, which can interfere with the decryption process. And then we can just print the output of the decrypt function. Also, I'll be using strroq, which I'll show you in a second. What is that? It's actually just the ASCII readable characters from roq, because roq contains some, you can say, unreadable, and Python 2 will complain with it. So I'll just use strings on roq and generate a strroq word list. So now Python shouldn't complain about it. Starting the file, we can see that it successfully decrypts it, but outputs a lot and we cannot analyze it. So I'll be using a variable, and I'll be checking if that variable contains any of the words mentioned. In order to do that, I'll first assign a variable to this output, which will be from the decrypt function. Then I'll use if in order to check whether these words exist in the message, and if it does, we'll just print that message. So it is checking for words like or, and, paint, backup, or key, and we run it, but still it does output each and everything. Now, after quite a while, I solved it. It was just the spaces between these hard-coded words that I gave it, and without them it would just output each and everything. I don't know why it does that, but like with the spaces, now it runs flawlessly. After quite a while, it will give us the decrypted message, and it says that this tool was developed by Paint, and it also gives us the key for an encrypted image in var backups recovery, which we'll be using with crypt setup, and it might contain some sensitive files. So let's see. We SSH in again using this password. Now we can go to var backups and see what does the recovery directory contain. Inside it, we can see that there is an encrypted backup.image, and we'll be using the first command, the crypt setup, in order to decrypt it and mount it to a device named backup, because of the second command, which mounts that device backup to MNT folder. Anyways, let's do that. We just paste in the password and argument, and the star in the sudo file means we can use any of the files, file name or anything as the arguments. It also requires the device name as the argument, which we'll be using as backup, because the second command only uses the backup name as the mapped device name. I forgot to use sudo at the start, so let me just do that. We enter the passphrase we found earlier, and it looks like it got executed successfully. Now we'll use the second command in order to mount that backup, and I again forgot sudo. Doing that, of course, because the .mnt, it will require us to be in the root directory. So what we did here was map this encrypted backup by decrypting it into this device called backup, and then mount it to MNT folder. This MNT folder is in the root directory, so we'll go there, and now we can again use the mount command in order to mount that. Now the MNT folder will contain the generic contents that the backup had, which is actually the ID RSA, which can be used to SSH in as root user. We copy the ID RSA to our local machine, and we will have to chmod it to 600 or 400 permissions because SSH would like to lock it in while it is using that. Using tag I with SSH, we can specify the ID RSA key, and now we can log in as the root user on /. So we get in and we can list the contents of the present working directory, which is the home directory, and it contains the root flag. So we successfully rooted the /. And let me just explain this once more. We actually decrypted the backup and mounted it to MNT folder, which contained the ID RSA file, and which we used for logging in as root user on the box. This was a really great Linux machine, and this was actually my second recorded write-up, because the first one I thought Cascade was gonna retire, but I think maybe it will retire next week, and that write-up I will actually say that that was my first write-up. So I'll see you all in that next write-up.